Hello, sir. Can you hear me?
Yes, sir. Yes, sir.
We'll wait about it, sir.
Oh, okay, sir. Okay, sir. Sir, sir. Sir,
Sir,
there is shorter wait for.
uh, once ma'am joined, we can start, sir.
Oh,
Hello, ma'am. Hello. Shall we start now? Yeah, yes, sir. Please, sir, proceed. Good evening to 100% here. Am I audible?
yes, ma'am. Yes,
Yeah,
ma'am.
yes, sir. Yeah, thank you. Thank you. Once again, I welcome you all for this last day session on design of footing. And I'm very happy to announce you that we have participants from many engineering colleges, PSP College, St. Joseph Engineering College, Kongu Engineering College, GC Salem, Bannari Amman Engineering College, AC Institute of Technology, Velamal Engineering College, JMET Mandia, Dr. Mahalingam Engineering College, TCE, and we have our own participants from Sedu Institute of Technology. Really, this program is a useful program, sir. We have got good feedback from our own students and from other college students also. People are eagerly waiting for your sessions.
Thank you.
Thank you so much, sir. Participants, once again, I welcome you all for this last day session. We'll straight away get into the session. At the end, we would like to hear from the participants from various engineering colleges. Thank you so much for your cooperation. Sir, shall we start, sir?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Thank you.
Good evening to one and all. Today we'll discuss about foundation, right? Basically, it is in the shallow foundation. One is the deep foundation, right? Today, small discuss about shallow foundation, right? The shallow foundation is normally used for our residential building, etc., right? Sir, my voice is audible.
Yeah, sorry.
Sir, YouTube live also audible, Laura, sir.
No, I will check with that
Ah,
and
okay.
I will inform you, sir.
Okay, sir. Thank you, sir. Okay. Today we'll discuss about footing design in STAAD Pro, how to check the manuals and etc. Right? Okay. Sir, my PPT is visible? Yeah.
Yeah, visible, sir.
Okay. First of all, this my PPT is my PPT. I prepared this PPT. Now it's 153 slide. It's a more than 170 slide. I refer from so many books, Shaw and code books. I prepared this industry pictures and Google also. Right. I prepared this slide. This PPT is useful for beginners also. Mainly, I refer the Shaw book is useful for creating the manual calculations, others, etc. And also prepare the IS code books, anything, etc. Right? Okay. First one, the footing creation. Right? All are known about types of footing. One is the shallow foundation. Another one is the deep foundation. Right? That is the main thing. One is a shallow, another one is a deep. Right? First of all, how to select the footing for your building, right? There are small conditions are there. First of all, how to select the footing for your building. The first is carried by column and bearing capacity of the soil. First of all, you will be started on building. The first procedure is anyone, you starting the building, right? On area is there, you would simply go to starting on building. Your first step is the starting step is anyone.
Soil.
Yeah, the soil testing, soil test is a most important one, right? The soil test is a most important one. That is the our human health, right? That is a soil test of the building. Is a human health is a air, our human health. The air is a main important to our breathing purpose. So the soil test is a same like a air for the building, right? That is a human is a building, air is a soil test. Sometimes you will be simply design your G+3 for normal building, but the soil is clay soil, the building will be collapsed, right? You simply design, yeah, you design for normal soil condition SBC value, but the soil condition is clay. Sometimes your building will be simply collapsed, right? That is a main condition. Okay, this is a basic condition for your building. The first one is a carried a column and load bearing capacity of a supporting soil, right? That is a main condition. You design the one single footing. You consider the what is the soil safe bearing capacity of your soil and what the load acting on your building, right? That is the main things to create a one single footing, right? Okay. The next one is you create a large projects like a big projects like a industrial building or education building, some others, etc. Right? You will be simply create the large projects means you go for plate load test, right? You simply go for plate load test. Once again, here on PDF. Okay. So now that PDF is now. I send this PDF to email respective mail IDs, right? There are so many conditions in our footing and etc. The slide have 178 pages, but some of pages are missing, right? I will search and send you a respective mail after the end of the class in, right? Okay, this is a drill hole test. This is the main test for the large area. For big projects, you simply test the plate load test for your buildings or anyone, right? The black cotton soils is a greater depth, right? The normal rock foundation is under the 4 meter or 2 meter from the ground level. You go to black cotton soils. The black cotton soils are greater depth, right? The black cotton soils are greater depth. It's a go for pile foundation, right? First of all, you choose the different types of foundations, right? You choose the different types of foundation. You simply your SBC value will be high It's a rock is go for normal isolated. The black cotton style is go for greater depth, simply go for pile foundation, right? The next one is a column is very closely, sorry, the column is very closely spaced bearing capacity is go for raft footing or other than foot strap footing, right? Strap footing, raft, sorry, raft footing, low raft foundation, right? I saw that the image, right? What is in by raft footing and other etc. The next one is a boundary line combined footing or strap footing provided, right? The normally the types of shallow footing is a anyone isolated footing, combined footing, strap, mat or raft. Another one is a strap footing. Another one is a eccentric footing, right? You know that eccentric footing. These are the main footing, right? The what which area will be eccentric footings are provided? Anyone? Eccentric footing. No, no, not a hill. Yeah. Another one, tell me. Boundary area, correct. The boundary area, the maximum will be provided for eccentric footing, right? This is simple example for this. This is your boundary, right? This is eccentric footing, right? This is eccentric footing is a different design from isolated, right? See this. This is one of our boundary, right? This is one of our boundary. If this building is another boundary, right? But the owner will be told that I starting from this end of our boundary line. You go to isolated footing, but you provide the column. The pedestal goes to another area, right? See this. First of all, you select this footings also. You started your foundation, right? See this automatically. This is your boundary, right? This is another one boundary. But the client already told that I started from this area. This area will be occupied. That simply go for eccentric footing, right? Eccentric footing. You simply provide a column for this based on design condition. This area you go for isolated means the center column will be provided. You simply design this area. You design the isolated means the pedestal half of the area go for another boundary, right? Understand? The boundary areas you designed only for eccentric footing. Nearby near maximum your city areas or another areas, the maximum nearby areas will be designed for eccentric footings like a boundary footings. Okay, now understand. This is a boundary footing like a eccentric footing. This is a normal footing, right? This is a normal footing is a ice spread footing or spread footing, right? This is spread footing. Then see this automatically the single column is combined with this is spread footing also. Two layers are there, bottom layer and a top layer. This is our columns, right? This is our top layer and bottom layer of the reinforcement. This is a column. This is so many. This is a isolated. This is a stepped footing, and this one is a combined footing or this places. This is so many footings are in this one column, right? What is this footing? What type of footing is this? Anyone? Raft foundation, right? Raft or mat, right? The so many columns in nearby space is less. You provide the mat or raft, sorry, raft footing, right? Your column will be you take a one building, right? The column will be less space, 1 foot, 1 foot. All footing will be minimum area, right? You simply excavated with all area, fully stop finished with the mat on bottom area, right? Fully finished with the bottom area, then provide the footings, right? This is called meta ref. First you decide your footing area which depend on what type of footing, right? One is the isolated footing for normal areas, the eccentric for boundary condition, the meta ref for the your maximum the lift provision is there. Lift area, what type of foundation will be provided? Lift purpose, what type of foundation will be provided? Same like a mat, right? The lift area, this one rectangle is there. The four columns, yes, ma'am. Yeah, four columns are there in one mat. The maximum in our residential building or any building, you simply provide the lift area, lift provision is a mat footing. The mat footing, one mat provided for four columns, right? That is called mat footing. This is, you first you will be, before you started your project, you will design the what type of footing, the boundary condition. This is my boundary condition. You select the eccentric footing. My like one lift is there. You select the mat footing. The two columns are nearby. My nearby. You go for combined footing or others, right? See the same like that. Okay, that is the different types of footing. The combined footing means will be combined with the two columns is nearby, right? That is called combined footing. The next one is a pile footing. The pile is already known. This is a pile load case, and the next one is a pile cap. Another one is a pile, right? The simply extra loose density soils, right? Maximum loose density soils is provided for pile. First of all, the pile will be extended into soil, then you created the pile cap, then normal column will be provided on this top of this piles, right? The next picture, what will we do for this picture? Why the pile cap will be broken? Anyone? Top of the pile cap will be broken for this picture, right? Why? Anyone? Top of the pile cap. Why means the inside of the pile cap will be concrete. The top of the pile cap will be only mortars, right? So we will be demolish that mortars. The any you go to any pile foundation, the top of the mortar will be demolished. This area fully only mortar, not a concrete. This area will be only concrete. It will be grilled and demolished this portion in this pile foundation, right? That's all going on. This also is our pile cap. This is single pile cap, two pile cap, three pile cap is there. This is our column. Normal column will be provided. The gray above the ground level, the pile will be provided and the pile cap and normal column, right? This is the same procedure. This is automatically this is our ground level. This is our pile cap, right? Pile, right? Normal concrete pile or steel pile or timber pile or sheet pile, any pile. This is our sheet pile, any one pile, concrete pile. Then this is a pile cap. Then this is a normal column, right? This is our pile above the ground level. Then this is a pile cap. Then this is the column, right? This is the main for this pile design. Go for in many types of pile, timber pile, steel pile and concrete piles, right? This is a basic for the pile definition, right? Then this is a normal eccentric foundation, right? Normal eccentric foundation. Once again, I will this is also same PPT, but some slide will be added. Yeah. This is a PPT. I missed that PPT, right? This is the same procedure. Will be seen. Next is our common types of footing, right? Our shallow footing, single footing, stepped, sloped, wall footing, combined footing like a slab type or slab beam type, step type, right? These are the main types of footing using in our building, normal residential building. The combined footing are three types. One is a slab type, another one is a slab and beam type, another one is a stab type, another one is a stab footing or mat footing, right? These are the main types of footings using in our building, right? Next one, this is the main condition. What are the checks for provided in your footing is compulsory? Anyone? What are the checks? The main checks is there. Anyone? What are the checks for your footing? That is a test. You will be designed on a footing, right? You will be designed on a footing. What will be checked for your footing is a factor. Yeah, this is the check for your footing. First one is the size of the footing, which size you will be provided. Another one is the upward pressure. What upward pressure you will be provided for your footing design. Then footing will be bending moment calculation is a safe or unsafe. Then two-way punching shear. The two-way punching shear is a safe or unsafe. Then check for one-way shear and check for base pressure. These are the criteria for checking for your footing is a safe or unsafe, right? You will be studied in your books, right? One is the size of footing and upward soil pressure is a safe or unsafe. Then you go to unsafe, you will be redesign it. Your bending moment for the depth, right, is unsafe or safe. Unsafe means you will simply design, right? Unsafe means do not use that footing, right? The safe means use the depth, right? The next one is the depth for footing required for two-way punching also. The safe for depth is two-way punching is a safe. You use that footing. Is unsafe means you will be redesigning it. Then check for one-way shear also, right? Check for one-way shear and check for base pressure also. These are the main checks for your once you design the footing. Checks for this all the condition is necessary, right? The next one is this is the critical bending moment. Which portion the critical bending moment will be taken on your footing? This is our footing area. This is our column, right? This is a longitudinal section. This is a cross section. This portion will be the critical bending moment will be formed. So check this portion will be for your calculation, right? This is the bending moment. Which area will be formed? This area. So 1 by 2 b minus d. This is a calculation is the this area only the bending critical bending moment forms in your footing. The compulsory you will check this area. It's common to mat or raft, combined footing or sloped footing, anyone, right? Bending moment. The critical part beam shear, one way shear. The one way shear is formed in this one side of this pedestal, right? Corner for this one side of this pedestal is a critical beam shear, one way shear. Compulsory you check that one way shear also safe for unsafe your build for footing and bending also, right? Next one is a how to act the punching shear. The punching shear is acting on your around the columns, right? This is the punching shear acting on this around this column. You check the punching shear is safe or unsafe, right? This is the main three condition you will be once you design your footing. You check this safe or unsafe for this punching shear and bending and upward pressure, right? This diagram is simply the which area will be provided for bending in your foot pedestal, right? This area, the beam shear, one way shear is formed in this area. For example, the beam is there, our beam, our rectangular beam is there, shear is there, right? Beam shear, the beam shear will be formed in this area. So provide the additional reinforcement others, right? Check this. And the bending will be form this center deflection. So form this additional reinforcement. Same as the same as this same procedure for this footing also. Critical bending form this area, they will be calculated it safe or unsafe, right? You provide the thickness for your footing, right? This also check for this, provide the thickness and this also, right? This is the main things to design the footing for your building, right? Punching shear is one is a punching shear is a main, one way shear and the beam shear and the critical bending moment. These are the main things to design the footings, right? This is the footing thickness. Some of the thickness in minimum how much will be provided for this reinforced concrete. So minimum thickness of the footing is 150 mm, right? Resting on soil means 150 mm. This is our pedestal, right? This is our footing pedestal. This thickness is a minimum for reinforced concrete is a 150 mm. This page is taken on NBC National Building Code 2016, right? This is resting on pile means 300 mm, right? Minimum. This is the condition, right? This is the main condition. Masonry, plain concrete is different types of concrete is there. minimum thickness for your footing depth, right? Now understand this table will be follow the minimum depth, right? The next one, this is for not required, this is a basic test, mass of soil samples required for your soil test, right? The National Building Code of 2016, excessive soil and sands and gravel, mass, how much kg will be taken for this test? Excessive soil take a 1 kg and sands and gravel 3, excessive soil and sands 12.5, gravel soils, which test? What test you will be provided? Soil and identification, chemical test, compaction test you will be take this someone, and compression examination construction, and other than testers gravel soil you take this type of kgs, right? Which code book you will be refer this type of values? Go to National Building Code of India 2016, right? The next one is the same as the limit per permissible limit per your shallow foundation settlements. The minimum settlement for our foundation is 25 mm, right? It will be 25 mm for the minimum foundation, right? The next one is the allowable bearing pressure. This is the main characteristics for allowable bearing pressure, right? This is already discussed about types of isolated footings, same like this. This type of footings will be discussed, right? Yeah, already discussed about same types of footings. This is a reinforcement diagram for this footing, right? How to find the reinforcement diagram for this footing? Simply go to SP34, right? Simply is the SP34 to take the reinforcement detailing for this footing, right? Okay. This is the same. Continue. You will be provided the normal footing is this type of reinforcement. This is minimum thickness, right? Already provided the 150 mm for the minimum thickness for your foundation, right? Then how to provide the reinforcement for combined footing? Same like that. SP34 code book. This is on nearby going on this bridge structure, right? This is a foundation. Sorry, bridge structure is going on, right? Anyone tell about what type of foundation will be do for this? Nearby 200 meter, the dam is there. It's a riverbed area. Anyone? What type of foundation will go for this area? Riverbed area. Anyone? No, wrong, ma'am. But my assumption also first as in this area is a pile. No, it simply is tested in soil. It's a fully rock area, rocky surface. SBC is so high. That same as this area is a riverbed area, but it has extracted as a fully rock area. So rock area means directly approved by normal isolated footing, right? This columns are designed by normal isolated footing based on the soil condition, right? You provide the soil conditions. See this automatically the fully rocky area, the SBC will be high. This go for normal isolated footing, same like that building. See this type and provided for this two sides. Then will be column will be increased, right? Same like that you will be design this soil type, you will be go for this type of any type of foundations in your area. In our one of by doing one consultancy project, the residential building, that is the residential building but it go for 14 feet foundation, right? 14 feet foundation, that is a clay soil. That is a difference. You go to simply assumption as a it's a river bed, you go for pile foundation, but I tested as a SBC. The river bed is more than 250 mm greater, right? SBC, but that residential building is a SBC is a too low, normal 130 140 mm, and then excavated more than 14 feet. This is a clay soil. Then I will be extracted some of the dumps in this hard rocks. Then I create this footing, right? That is the different normal difference between residential building and you go for any building based on the SBC value. Main you go for any building, you start at the normal residential building or any building. You first of all you test the soil condition. The river bed is directly go for normal footing also. but the residential building is a low SBC. Go for additional, will take the footings, right? Okay, now understand. This is a simple difference for your real life structure. This is a riverbed, but you go for normal foundation, right? Isolated footing. Why? Simple. The SBC will be high, the soil test. So it's go for high foundation, right? See this. This is a simple one for your buildings, right? This is some of the earthwork. Okay. This is a one-way load distribution. This manual calculation in my YouTube channel also. I send this slides also in your respective mail. This is a one-way slab load distribution. Yesterday we'll discuss about one-way slab. This is a manual calculation also. This is a one-way slab and two-way slab distribution. Next one is the main thing. You will be create a one framed structure, right? Framed structure, other designs, etc. How to create the detailing like that, right? Detailing like that. How to create the detailing? This type of detailing. The first one is a prepare for key plan. Already show that, right? Already show the first one I created in Revit, right? Grid lines. uh, A, B, C, D, F, G, H. The same procedure will be followed this diagram, right? See this. The first plan is a key plan for your building. That is a key plan. The next one is a column layout. You provide this type of diagram. You provided for your column layout and the column reinforcement and beam layout and beam reinforcement and slab reinforcement, footing layout, provide the F1, F2 is a footing dimension, right? The footing cross sections, etc. Right? Okay, little bit later we'll discuss about, right? And then how to design the footing in our STAAD, right? Then how to design this is the basic introduction for your footing. You simply go to take a SBC and then loads, then what are the checks are there? One way shear and two way shear and base pressure is there. Then go to design the detailing for the center line, right? Then how to design the isolated footing in our STAAD foundation, right? How to design the isolated footing in our STAAD foundation. Yeah. I take this same picture, right? First day class we will be created. Most of us the you will be take the moment and load is they simply created the Excel sheet also, right? That is the best method to create the Excel sheets, right? Yeah. First of all, once you open, simply go to run analyze your structure, right? So, okay, then go for foundation design, right? How to design your foundation? Simply go to foundation design, then I take the combination load included the foundation design line. I simply take the combination load, go to run STAAD foundation, right? Go to run STAAD foundation, the automatically the STAAD foundation will be open, right? This is the STAAD foundation. Automatically the STAAD will be import to the STAAD foundation, right? Yeah, this automatically our the foundation will be the moments and the loads will be automatically transferred to that foundation, right? The simple step I will be tell. First of all, simply go to job setup, right? Simply go to job setup, then go to create new job, right? Go to create new job, then go to job name is I create isolated footing, right? Isolated job type also isolated. You will be design the mat footing, combined and pile cap also. Isolated design code is a Indian, right? Indian, the SI unit, select this load, right? Available load case, I select this combination load case for my foundation and create job, right? Automatically the job will be created. Then click this one, then click this three parameters, right? This is the three main parameters: concrete and rebar, cover and soil, footing and geometry, sliding and overturning, right? How to design your footings? First one, concrete and rebar, right? What is the unit weight of our concrete is M25. You provide the minimum and maximum bar spacing. Your strength of a concrete is a M20, and yield strength is a 500, and bagger size is a 1212. I simply give yes as a default. I do not change this, right? First is over. Next one is a cover and soil. My soil type is a drained or undrained, right? The next one is a bottom cover. I fixed the bottom cover already. My unit weight of the soil, that is a SBC. This is a main. What type of soil for your building? My soil is a SBC is high. You provide this SBC value is based on your soil condition, right? I provide simply 250. The depth of the above the footing level, right? What is the depth of the above the footing level means? This is our ground level, right? This is our ground level. First of all, you excavated the depth, right? Simply excavated that, right? This is our base, right? This is our rock surface. I complete this portion. Then the ground level to this bottom portion height, that is called depth of the foundation, right? This is 2 meter. 2 meter height from ground level to bottom. That is a 2 meter height. My ground level to depth of the level. I simply enter 2 meter, not a 2 meter. You go for 1.5 meter or 1.58 meter. It will be different, right? This condition is the main condition. This is ground level, the ground level to bottom level, right? The next one is the you go for water surface area. Okay. First of all, you simply design this normal area 250. I simply created yes. I create this default, right? The next one is the footing geometry, right? The footing geometry. The footing type is a sloped or spread footing, right? First of all, I simply click sloped footing, right? Two types of footing is there. One is the spread footing is the uniform thickness. Another one is the sloped footing, right? Then you go for another one, the designing calculations. So fixed width or fixed width, simply click calculate dimensions, right? Then go for yes, simply change this, go for yes. Then sliding and simultaneous is aircraft safety is a 1.5. Then go to design, yes, right? Simply design, change. Once you design this, automatically it will be imported to your STAAD foundation. Then click this SBC value and depth of the foundation. Automatically you will be design what type of footing is spread footing or isolated footing in your building, right? Okay. This is a geometry. This is a detail diagram. This is a title about GA drawing. This is a calculation sheet, right? This is a calculation sheet means our footing is a 12 feet, 12 footings. This is the length and width of our footings, right? This is the thickness of our footing, right? So slope and thickness. This is a reinforcement, right? This is a manual calculation for this footing, right? Sliding and overturning. Then check this final dimension and values, right? This critical trial depth for against this moment, and then shear plan, one way shear depth check for one way shear is a safe, one way shear in Z direction, two-way shear same like a book also, two-way shear and section reinforcement. Once you will all build false, automatically it will be designed. Someone has fails, you will go for redesign it, right? Says automatically. The next footing, so footing dimension, plan value, footing 2, design value, design footing calculations, the load conditions, contact pressure area, then check conditions, right? Moment condition, ends it's safe, and depth against the moment, this also safe. Then one way shear, this also safe. One way shear in Z direction safe. Two way shear, it will be safe. Maximum bar size safe. All are safe, right? This is design is safe. You will be provided for this site war, right? Now understand. The same calculation will be follow on STAAD Pro also. The book calculation will be follow on STAAD Pro also. Then how to take the center to center dimension for this footing layout, and how to take the detailed diagram for my footings, right? How to take the detailed diagram for my footings. First of all, go to detail and schedule drawing, right? Detail and schedule drawing. This is a number one footing. This is automatically, this is a cross section. This is a 1.8 meter. This is a width is a 1.65 meter. The reinforcement will be 2 mm dia, 7-inch spacing at both sides, right? Then the cross section, right? The slope, what is a 0.2 mm thickness, and our slope is a 0.11 mm thickness, right? This is also exported to AutoCAD also, right? I need this another footing. I need 10th footing says automatically 2.05 meter 1.7, right? Then this is also cross section. This is a zero point 0.3 depth of our footing. The sloped thickness, right? Next one is a schedule. The schedule will be all the dimensions comes under one sheet, right? That is the schedule. Next one is a graphical drawing. This is the first of all you give the main drawing for the building design, right? See this automatically one footing, two, this all are makes the center to center dimension. See this, these are not all are isolated footing, right? Sometimes will be clash on this portion to this portion will be automatically considered as a combined footing, right? Automatically considered as a combined footing. Otherwise you go for isolated footings. Is automatically designed in our building, simple building. This are exported to area, right? Okay, this is the small design for our footing. Next one, how to design the isolated footings, right? Simply go to job setup, create new job, combine footing, go to combine the Indian SI load case, right? Load case. Then what are the footings will be selected for this combination, right? What are the footings? First of all, I create this two footings. Simply go to geometry. I select this two footing for combination. Select this, control and select this. Then go to create job. See this automatically it says a combined footing. Create job. Then go to create from selected nodes. Click this. This automatically it's created as a combined footing, right? This automatically strip footing. Simply go to footing 1 support 19 and 2 are combined, right? Same procedure, simply go to load case and load case 2, simply add the combined footing, right? And then go for how to design the combined footing. Simply go to combined footing, design parameters, same. Concrete and rebars and others you will be simply design it. Yes, okay. The next one is a cover soil and safety for this footing. Simply says automatically you will be take this design. Yes, and then go to footing geometry, right? Calculation dimensions. You also need the beam depth. All of us that. Simply click yes, then go to design. Yes, this automatically the combined footing will be designed. Our footing dimension, this is a cross dimension for this footing and manual calculation. Simply go to detail drawing. This is automatically our footing cross day. This is a cross the beam footing and slab thickness footing, right? You go to simply go to detail, see this automatically. This is our beam and slab. What reinforcement will be provided for this beams and slabs and others etc. for this combined footing, right? The ZA drawing automatically says the combined footing for this portion and calculation sheets also, right? What type of combined footing will be provided, then what type is the over length and measurement also, right? This type will be simply designed for this combined footing others etc. I go for normal footing, simply go for normal footing, right? I go for isolated footing. Detail drawings is automatically export to AutoCAD, right? Okay, now we understand. Then you check, simply design your footing, but check the two-way shear, punching shear, and bending, etc. and upward pressure also. That is the main conditions, right? Now it's like I simply completed this footing level, right? Simple. Then go to how to export the drawings and other reports in your stat file, right? And how to export the stat files. Simply go to file. First of all, how to export this picture into Word file, right? Right click on your mouse, go to take picture. Okay. I need this 3D diagram for my picture, right? This go to take picture. Okay. I need this shear diagram, right? Go to post processing. Okay. Combination. I need this moment value diagram. Right. Go to view value, beam result, mid. Okay. Go to take picture, right? Then I need also shear also, right? Simply click this shear, same as a take picture. Okay. Then how to export this all the diagrams in one Word file? Simply go to file, go to report setup, right? Go to file, report setup. I simply go to pictures. I select the four pictures this side into this side, give okay. Then go to file, go to export report in ms word file, right? Ms word, simply save the any other file name, save, and automatically it will be open, right? Open. This is automatically your STAAD Pro report. Space frame or node points and other load combinations, whatever will be load case, what type of load case will be created, self weight or brick weights, others, etc. Right? Then also diagram also. See this automatically our 3D frame bending moment diagram will be take the all the diagram. It will be increase the sizes also, diagram sizes. This automatically take the all the reports, right? How to take the values in report? Simply go to file, go to report setup, right? Then go to output option, right? Then go to output option, then go to I need a beam force reaction summary. Simply take this same procedure. I need a base pressure. Simply click this, automatically go to OK. Then export to Word file, right? Is the basic for exporting the STAAD Pro, right? Now itself, I simply created the design, right? I simply created this design. And how to create the key plans, column layout diagram, others, etc. That is this procedure. How to give the diagram for your buildings and a commercial building or any buildings, right? This is the procedure. This type of procedure will be follow. Give the diagrams for your building, commercial or industrial. First one, you will give the key plan for your building, right? Key plan is a column marking diagram. It's the first procedure, right? Key plan. The next one is a column marking, right? Column marking, what type of column will be marks in your number, right? C1, C2, C3 are same columns. You will mark the same reinforcement, you mark the column numbers. Next one you give for column reinforcement. The what purpose you give for A, B, C, D and 1, 2, 3 is This automatically our column adopted A5 A6. The column number is C1, right? For example, our column number is C1. The what grid line will be there? A5. This automatically A5 that number. And next one is the A6 and A7. See this. Identify this column adopted numbers, right? Now understand what purpose you will be give the this type of grid lines for your reinforcement number. C1 or C1, C1, C1 are common reinforcement for all the columns, right? The 5, 6, 7. Simply go to my column adopted is A5, A6, A7. What C1, right? The serial number is C1 column. This column, what is A5, A6, A7? This is a A series. That column number is A5, A6, A7. Right? Now understand. Next one is a B1, B1, B2, B. Sorry. Next one B1. Another one is a B11, right? See this automatically. First one is a B1, another one is a B11. Now understand the grid line is a this purpose. Identified the reinforcement, which reinforcement for this column. That is the grid line diagram. Now understand. Next one is a CL3 column. CL3 column is there. The B2, B3, B4, right? B2, B3, B4, and B8, right? This is the B8, B9, B10. B8, B9, D10. Now it's identified that easily, right? This pressure only the grid lines will be forming, right? This is the beam layout diagram. See this mentioned this beam number, beam sizes also. You provide the beam numbers. Next one is the beam reinforcement. You provide the longitudinal section also, cross section also, right? Understand? You provide the cross section and longitudinal section. This is also slab reinforcement. You provide this slab. So one way slab means provided this only this direction, only this is a direction. The two-way slab means you provided the two direction, right? This is slab direction. This is a reinforcement, slab reinforcement. You provide the footing. This is our single footing means provided this type. This is the raft footing. Provide this raft footing. Combined footing means the type of footings you provided for this layout. See this is a combined footing. This type of will be shown in your diagram. This is a reinforcement footing, etc. Right. The layout diagram. This is some of the building, another building. This is automatically this is a build. Some see this automatically the column depth is longer beam side. This is the main concept. This is a beam two section will be taken. This is the end span, mid span. The mid span is a tension zone. End span is a compression zone. Right now understand. The what purpose will be dark commands is that the provide the extra bars. I have a 16 bars in four numbers. I simply provide the save for extra two bars, right? These are the side reinforcements are there. Side reinforcements are more than 700 mm. You provide the side reinforcement, right? Provide the side reinforcement for this bars, right? This using for this fields also, right? This type of reinforcement detailing. These are the slab detailing. What is the lintel level and slab reinforcement? What will be rod will be provided, and the others, etc. Right. This is the practical size for your slab thickness and depth and beam depth, others, etc. Right. Okay. Now itself I completed the 5 days class for today's session now. Now itself I completed, and then I share something my notes for my YouTube channel already will share. So Raja sir will be share my same as I use YouTube sorry slides as STAAD Pro notes in our respective mails, and also any queries and any content we will contact on my number, and otherwise you will be go for mail also, right? Okay. Thank you for your cooperation for 5 days. Now itself I completed this class for 5 days. So any doubt will be directly asked me. Right.
Thank you, sir. Thank you.
Thank you.
We would like to hear from you. One or two people, you may share your feedback about this trip. Participants, anybody from other colleges? Could you please share your feedback?
The session was very informative, and sir taught it very clearly for a train. It was a proper trainee who could teach us like this for the from basic till the like what stage we should learn as an engineer or designer. So thank you, sir. Thank you so much.
Thank you, ma'am.
Thank you, ma'am. Anybody? Any students?
Ma'am, shall I?
Definitely.
Okay. Good evening, everybody. This is Dr. Oliver from the Department of Labor. Actually, I had a privilege of attending this session, especially it was refreshing to me. I learned two techniques daily. Actually, I thank management and principal, in particular, our head of department has been there for us, especially choosing a correct person for a correct job. So she wonderfully started with the fundamentals, how to install, then it moved on to beams, canvas beams, and the support, then finally end up with foundation design. Really, it was a boon for everyone like you, those who have forgotten STAAD over the years. And especially hope our students might have been benefited, and also the staff from other institutions. And really thank Uday Shankar sir for his valuable time and his service. Really, it's a service because he was very much comfortable, and he was very much comfortably and narrating everything one by one and slowly and quickly. It was very superbly simple so that any layman can understand easily.
Thank you, sir.
And really, we are just a map. And I hope your collaboration also will be continued. And thank you very much for your valuable time and service, sir. All the best, sir.
Thank you, sir.
And I thank all the participants, and especially I thank Lovraj sir and all the organizers who are organizing Friday event. And especially timing was comfortable. Especially the 7 o'clock time was very comfortable, so that I hope many professors at home and especially those organizers who are having this time will be very much comfortable, I hope. And really it was very useful one. I hope to learn more from you, sir, in future sessions. Thank you, madam, and thank you, Uday Shankar sir, and thank you, Lovraj sir. Thank you for the opportunity.
Thank you, sir.
Thank you, sir. Thank you so much. If you don't have any queries, lower sir.
Ma'am.
Thank you, sir.
Thank you, sir. So one more, I tell me anyone I subscribe my YouTube channel, please subscribe. I conducting more than colleges in our Tamil Nadu.
Ma'am, can you hear me? Yes, ma'am, can you hear me? Hello?
Yes, sir.
The ma'am is left.
Hello?
Hello, Raja sir.
Sir, you tell about your YouTube channel, let them know that so that if they have missed any of the classes, they can utilize
Yes,
the
sir.
channel.
Otherwise, in future YouTube, I taking the many colleges. Future will take the classes same as live from my YouTube channel also. I taking a 5 days class in Revit in another college. That same way, I will live in my YouTube channel also. You will benefit also. You will like take any colleges in anywhere. Will live in my YouTube channel. You will watch and benefit for this. Any queries, we will ask my YouTube comment box also. No problem. So sorry sir, that the YouTube link is not valued. I send this valued link, sir.
We have arranged low to propose vote of thanks. Due to network issues, he was not able to join, I think.
Yes,
Anyhow, thank you so much for thank you so much, Uday Shankar sir, for your valuable presence in this meeting.
thank you, ma'am. Thank you, ma'am.
For the past 10 days, wholeheartedly to taught all whatever you have learned, you have you didn't hide anything. You have revised all the codes, IS 46, 2000, SP 16, SP 34, IS 875, part 1, 2, 3, 4, 5, SP 34. You have revised almost all the codes. And wherever it is required, you correlated with the code books also. You opened the code, you simply you would have told about the data. Instead, you have opened the code and showed the values. That shows your interest in revealing the things to the students and others. It was so nice. We thank wholeheartedly for your valuable time. We thank all the participants from various engineering colleges for the support and your participation and learning thirst is the success of this program. Thank you so much. We thank Mr. Lograja who has taken effort to conduct all the programs. And I thank our department faculty members who are participating here and students also. Thank you so much for one and all for your great support. Thank you. Thank you so much, sir.
Thank you, ma'am. Logaraja sir will be
Joined.
yes, ma'am.
Raja, sorry. Anyhow, we would like to hear from you also.
Yeah, yes, ma'am. Actually, I would like to start few things. Our department, for kind information to all the participants,